All right, guys. We're going to do day 17 notes right now. These are the last notes in the packet, so that means the summative test is coming up. So, pretty similar to what we did when we were finding arc length, but just a slightly different formula. So, what we're looking for is the area of a sector, which basically means, if I look down here at the worked out examples, the area of a sector is going to be like this little slice of pie. So, we're looking for that area when we're doing this. So what we're going to use to do that, there's two ways. For our purposes, we are just going to cross this way off. That's the way to do it when it's in degrees. And we're going to focus on the formula you use when it's in radians. So the same thing when we were finding arc length, you're going to need to convert anything in degrees into radians for this formula to work. But basically what the formula is the area of the sector is going to equal half times the theta times radius squared. So I'll write that so it's a little easier to see. But area is going to equal half times theta, which is that center angle, times radius squared. So we can look right here at where this is. They're telling us that center angle, or my theta, is pi over 3. And then my radius is 5. So I'm just going to basically do area times half times theta times radius squared, so it's 5 squared. And that's it. Okay, so we're going to go through a couple examples. So we'll look at example 1 right here. They're giving us all the information that we need. I know my theta is pi over 6. I know my radius is 12, so I have everything I need in order to solve for area. So again, I'll write down the formula so we start getting that stuck in our head. Area is going to equal half times theta times radius squared. Now we're just plugging in. Area equals theta, so half times pi over 6 times 12 squared. And now we're just going to start simplifying. So first thing I'm going to do is multiply this half by the pi over 6. So 1 times pi is going to give me pi, and then 6 times 2 will give me 12, so I end up with pi over 12 times 12 squared is 144. Make sure we square that exponent first before we start plugging in, just order of operations wise. So now I'm left with area equals 144 pi, right? That times that, and then if we just think about it being over a 1, 12 times 1 is 12. So 144 divided by 12 is 12 pi. So this area of that sector, of that circle, is 12 pi. And then my units is centimeters. So centimeters squared, since we're doing area. Okay. Example B. Same thing, but remember what I said. We have to use radians to do this. So this is in degrees. So I'm going to need to convert this into radians for this formula to work. So if you remember how we did this, this is what we did last week. We're going to multiply 60 over 1 times pi over 180. All right, so that ends up with 60 pi over 180. And what you can do with this is, one, you might be able to see it and just do it in your head, but if you can't, when we do this in our calculator, we're not going to use the pi, so we're just going to go 60 divided by 180, and then you have that math button, and then hit enter, and it'll give you the fraction as 1/3. So that means our theta is going to equal pi over 3. You can write 1 pi over 3 if that helps, but generally this is the way that people are going to do it. So once we have the angle converted in radians, we're going to use our formula is area equals half times theta times radius squared. So area is what we don't know. All right. Half. That theta we just figured out. So that's pi over 3 times radius squared. So that would be 4 squared. All right. Start simplifying. So I'm going to multiply 1 times pi. It's going to give me pi. 2 times 3 is going to give me 6. Times 4 squared is 16. All right. It's going to end up with area equals 16 pi over 6. And I can do that same thing with my calculator, right? 16 divided by 6, math button, enter, enter. And that's going to give me a fraction of 8 pi over 3. And remember, don't put the pi into your calculator. You just have to know that's there because we're looking for the exact answer. So we want to have that pi, not like a decimal place or anything. So the area of this is 8 pi over 3. And again, our unit is centimeters, so that would be centimeters squared. C, we're doing the same thing. I'm going to leave this one for you to try. They're giving you everything you need, right? I have this angle. All right, it's in radians already, so there's nothing to convert. I have my radius here is 8, so you just plug in the information into the formula. Area equals half theta times radius squared. All right, and see if you get the answer. Check the key online, or if you want, you can also shoot an email, and we can get back to you on the email. All right. Example 2, we're again doing the same equation, right? So we're doing area equals half theta times radius squared. The only difference is now we're looking for a different piece. So in this one, I have the area and I have the radius, but what I'm looking for is that theta. That's my unknown, or that's my variable. So we're just going to plug in information and solve just using basic algebra, right? So area is going to be 6 pi equals half times theta times radius squared. So again, I'm going to start simplifying. 6 pi equals half theta times 81. I can multiply a half by that 81. So I end up with 6 pi equals theta times 40.5. And then if I want to solve, I want to get this theta by itself. It's theta times 40.5. So I'm going to do the inverse operation and divide that 40.5. That will cross out. All right. And now I'm going to do the same thing in my calculator here. So I'll go 6 divided by 40.5. I'm not going to put the pi in there, but I'm going to know that that's going to stay. I'll go math, enter, enter. And that's going to give me a reduced fraction of 4, and I know I have to tack my pi on there, over 27. So my theta equals 4 pi over 27. I'll do B with you, and then I'm going to leave C for you to do. So in this one, I have my area, and I have my theta. So what I'm missing is that R. Okay, so my formula is the same. Area equals half theta times radius squared. So let's just start plugging in what we have. Area is 12 pi equals half times 3 pi over 4 times radius squared. Simplify. So I'd have 3 pi over 8 times radius squared equals 12 pi. Again, it's 3 pi over 8 times radius squared. So I'm just going to do the inverse operation. I'm going to divide 3 pi over 8, which would cancel. And then I'm going to go 3 pi over 8 here. These pi's are going to cancel. You should also just know a radius is not going to have a pi in it. All right, so when I do this in my calculator, I'm going to do the same thing I've been doing. 12 divided by, now use parentheses here. So I'm going to go parentheses, 3 divided by 8. I'm going to close my parentheses, hit enter. All right, and that gives me 32. So radius squared equals 32. Now, I don't want the square, right? I want just R. So in order to find R, I need to take the square root of that, right? So R equals root 32, which I can simplify because I can break that down into root 16 times root 2 and pull my perfect square out, 4 root 2. So the radius of that is 4 root 2. Okay? So C is the same thing. So go ahead and try C. Here's a trick though. It's in degrees. So make sure you convert to radians, and then you're going to use that same formula. So area equals half theta times radius squared. Okay, so then you would just plug in the numbers right there. All right. I'm going to do one more example and leave that last one for you. I apologize. My son is getting bored with his e-learning, so he's chatting to me a little bit. So sorry if you're hearing strange noises. All right, example 3. This one is going to call back a little bit to what we did with the arc length. So if you remember the arc length formula was that S equals theta times radius, and S is the arc length. Okay, so we're going to have to use that. So it says, given an arc with a length of 5 pi and a circle with a radius of 10, find the area of the sector formed by that same arc. So our problem is this. Our formula is half times theta times radius squared. In the information they're giving us, I don't have the theta, right? They give us radius, but we don't have the theta. So we have to use that previous formula, the arc length formula, to find the theta. So that formula, arc length, so it gives us the arc length is 5 pi equals theta times the radius. That radius is 10. So basic algebra, right? This is the variable. It's theta times 10. So to figure out that, I need to do inverse operation. Divide by 10. Divide by 10. So that theta is going to equal 1/2 or pi over 2. All right? So now I have my theta. Now we can start over here and plug in the numbers for area. So area is going to equal half times pi over 2 times 10 squared. All right? So that would give me, when I start simplifying, 1 times pi is going to give me pi over 4 times 100. All right? And area will equal this. So then I'd end up with area equals 100 pi over 4. That's going to simplify down. So that area, that sector, is 25 pi. What are we in? I don't know if they give us a unit. We'll say it's centimeters because everything else is centimeters. Centimeters squared. Okay? This next one on the bottom is the exact same idea. So why don't you try that one? Check the key, see if you get it right. If you have questions, let us know. And that is day 17. So that's the last notes we'll be taking. We got a summative next week. If you have questions or concerns, make sure you're contacting us via email so we can get answers for you. Thanks. Have a good day, guys.